you ever seen solid figures in your life? In your surroundings? In your home? In your school perhaps? I'm sure you have. Solid figures are everywhere. We encounter them, we use them. Take this cube as an example. This is, thus, a solid figure. And today, I'll be demonstrating on how to make a solid figure such as this cube. In making a solid figure, we should see to it that the following materials are present. First, we need a pencil. Next is a pair of scissors, a roller, a scotch tape, and, of course, a cardboard. Theorem 1 states that two intersecting planes meet in a straight line. So we have here the cube, which will be our solid figure. So we have here plane A and plane B. So as what you can see, plane A and plane B intersect and they meet at this side. So as what you can see, this side is a line, a straight line.
Theorem number 2. A plane is determined by a line and a point not on the line, two intersecting lines and two parallel lines. I have here a solid figure. Let's say this is point A, point B, point C, and point D. Point A and B, when connected, makes up a line, and with point C. So, a line and a point makes up a plane, which is supported by corollary number 1, stating that a plane is determined by three non-collinear points. So point A, B, and C are three non-collinear points. And the second condition, a plane is determined by two intersecting lines. This is line B and C. And this line here is line D and C. So line B and C intersect at point C. So this statement is supported by corollary number 2, stating that a plane is determined by two intersecting straight lines, this line and this line. The last is, a plane is determined by two parallel lines. Line AB and line CD are two parallel lines. So as you can see, this is a plane, and it is determined by these two parallel lines. And this statement is supported by corollary number 3, which is a plane is determined by two parallel lines.
Theorem 3 states that if a line is perpendicular to each of two lines at their point of intersection, it is perpendicular to the plane. So we have here plane A and line 1 and line 2 and line 3. So the point of intersection of line 1 and line 2 is this point D. And line 3 is perpendicular to these two lines at, of course, at their point of intersection, which is point B. So this line 3 is perpendicular to this plane A.
Theorem 4. Through a point, there is one and only one plane perpendicular to a line. We have here plane B, point F, and line 1. Plane B and line 1 intersect at a point which is point F. So, as what Theorem 4 stated, to a given point, there is one and only one plane perpendicular to a line. Therefore, line 1 and plane B are parallel of Theorem number 5, stating that through a point, there is one and only one line perpendicular to a plane. We have here plane D, point S, and line 1. line 1 and plane D intersect at one point. So, as what Theorem 5 states, through a point there is only one line perpendicular to a plane. So, line 1 is perpendicular to line D through their intersection point S. The last theorem that I am going to demonstrate is the theorem number 6. Theorem number 6. Oblique lines from a point to a plane meeting the plane at equal distances from the foot of the perpendicular are equal. And conversely, two oblique lines from the point to a plane meeting the plane at equal distances from the foot of the perpendicular. So I have here plane M. In plane M, there are 3 points, three non-collinear points, point B, point A, and point C. Point B and C, when connected, make up a line which is line BC. Point A and C, when connected, also makes up a line which is line AC. Line BC and line AC intersect at point C. And given there is a line which is line 1. Line 1 is perpendicular to plane M. This point, let's say this is point P. To prove the two oblique lines in theorem number 6, these two lines, line PA and line PB. Using the SAS postulate, this makes up a triangle. So using the SAS postulate, given that line AC and line BC are equal, so using the SAS postulate, triangle PCA and triangle PCB, under SAS, they are equal, they are congruent. So under CPCTC, this line PA is equal to line PB. And that proves theorem number 6. Thank you for watching,
and we hope that you learned something.
and may this video may serve as a guide towards the remaining theorems.